Computers are digital, but nature is analog. We live in an analog world. Now, I'll define what I mean by that in a minute, but consider these kinds of things: sound, light, power, pressure, distance, time, loudness, pitch, length, many other qualities of nature around us are all analog. What we mean by that is that analog varies continuously with infinite values between points. So think of a clock here, and if you look at this clock carefully, you'll see that this second hand is partway between the 4 here and then the next second here. So 20 and 21 seconds. So we're about what, 20 and a half, maybe a little bit more than 20 and a half seconds right here. Well, with a digital clock, there's no such thing as 20 and a half. It's either 20 seconds or 21 seconds, and that's all you get. You can't have an infinite number of variation between it. Records are analog, and CDs are digital. This brings up an interesting idea that came up a long time ago with a Greek guy named Zeno, who came up with the dichotomy paradox, or the law of infinite divisibility. He says, hey, suppose that John and Sam here are standing across the room, and John starts walking towards Sam. Well, let's say that they're, I don't know, 10 yards apart. So he walks part way, now he's 5 yards apart. And then he walks part way again, and now he's 2.5 yards apart. He walks part way again. Well, you get the idea. I can keep cutting it in half and cutting it in half. Well, according to Zeno's paradox here, he can never touch Sam. Why? Because you can always cut the distance between them in half again. Let's suppose that he's now only 1 micron away from Sam. Well, now if he goes a little bit farther, he's a 1/2 micron. And then he goes a little bit farther, and he's a 1/4 micron. And so on. Well, there's no number in the world. You cannot invent a number that cannot be cut in half again. So he could never touch Sam. Interesting idea. In the digital world, digital values are discrete steps. Now, I notice I made discrete with a single E here, not a double E. If I put a double E there, it would mean discrete like secret. But in this case, discrete means like bullets. You can't have a partial bullet. You can only fire one whole bullet or no bullet. And so that's what we mean here by discrete steps. So 1 and 0 cannot represent things between it. I can't represent 0.3 with just a 1 or a 0. Now I could come up with a way of representing it by combinations of 1s and 0s if I define them that way, but I can't represent with a single 1 and a 0. I can't represent something in between. So this creates a problem. Let's take a system like, I don't know, pitch, for example. If I have infinite numbers of wavelengths, so that I can create a pitch that's we'll define as 5.3 here, and digitally I can only represent pitch as a 5 or a 6, that means I have to make a decision. I have to decide, is this 5.3 going to be a 5 or is it going to be a 6? Well, here it's a little bit closer to 5, so I'll define it as a 5. But you see, I've lost some information here. That 0.3 cannot be represented. This is why some people love vinyl records. They are analog. And since they can represent an infinite number of pitches and an infinite amount of loudness, really they have a richer sound than digital music. Now, why do we like digital music? Well, besides the fact that we can manipulate it on computers, we also like it because with digital, it's easier to screen out noise, and so you get a cleaner sound. And besides that, the steps are so close that our ear can't easily distinguish between the two. But really, when you get down to it, that record is producing a richer sound because it can represent infinite numbers of pitches and infinite numbers of loudness and so forth. Now the same would go, of course, for color, loudness, or any other natural phenomenon I want to represent. As soon as I digitize it, I lose some of the richness of that information. So that's it for analog and digital.